That seems to be live. Let me just check that Twitch has caught up. Okay. Yep, perfect. I am live. Hello everyone, welcome back to the stream. Sorry for the very long break. I think I missed 3 weeks. Basically, without going into details, health issues. I was not able to stream for a while. Even last week, where I was hoping I would be able to come back, I was feeling better, but just staying in front of the camera for 1 hour felt impossible. So I preferred to be safe and move it to this week and wait a bit longer before coming back. Which is, in terms of timing, pretty bad because I'm on vacation starting next week. So I have this week basically, and then I'll only be able to resume at the end of the month. So there's going to be a pretty long break in the project. I'm sorry about that. But still, this week, we can try to make some progress and see how far we can go. So let's do that. I have zero recollection of where we were last time, what we did last time. I think last time we did this simplification thing. We added a new phase to the analysis. Basically, we split the analysis into two phases, and we added this simplification phase that operates after type checking has occurred. And it allows us to do this rewrite thing where we rewrite expressions to simplify them. This is one form of optimization we can do as purely a form of AST rewrite. If I remember correctly, it's basically, if we know the value at compile time, there are a few things we can short circuit. For instance, a Boolean AND. If at compile time we already have a true on the left-hand side, or we already have a false on the left-hand side, we can simplify that expression. So we introduced that new phase. Something I think I wanted to do for the next stream, which was supposed to be 3 weeks ago, was to start introducing tests, since now we have a phase that has been somewhat isolated. But the other thing we were working on was to continue work on the core of the analysis and to try to finish type checking and name checking of functions. If I remember correctly, we were still in the process. We are almost finished with expressions in the context of a function, which is different from expressions in the context of a constant. And yes, this was the analyze function expression function, which was a gigantic thing, and we had done most of it. We have a to-do here for instantiation. Yes, that's something we haven't done yet. Yes, last time we did all of the binary operators, the addition, subtraction, multiplication, and so on, that I do remember. And we have here this, which is the things that are not handled yet, that we need to finish handling to make this case impossible, basically. I think this evening, since it's been like a pretty long break since last time I streamed, I think I want to go back to this analysis thing because my goal was really to try to get it finished. And depending on whether I will definitely stream on Thursday. I was trying to see if I could make a third stream this week, maybe tomorrow or maybe Friday, to try to catch up a bit. If I can, I'll do a stream of adding tests for the things we have finished to try to leave the project in a better state before I go on vacation. My vacation will be not as long as my sick break, but, as a matter of principle, trying to leave things in a good state. So here, what's missing? I had here, yes, comparison expression are a thing that I commented out last time, and that's because, if I remember correctly, there were some things that were unclear about the way to compare struct expressions. If I remember correctly, last time we changed the way structs are compared in constants, and for functions. Hello, how are you? And for comparison, for struct comparison in functions, a big thing I wanted to figure out was whether we could solve them at compile time. And basically, could we reduce the expression of the comparison to basically the bare minimum of the comparison. And I think I had decided that no, actually, I don't want to do that at this stage. It will be a lot easier to do at code generation time. And I think for now, I just want to output that we're comparing two structs if we don't have their values at compile time, basically. So I think a lot of those comparison stuff we had left commented out because some of it was not correct for structs. Maybe we had finished it. Let me see. Ah, no, okay, this is what we had done. We had added a maybe t on top of the stack of the analysis here, and basically this whole function returns like a maybe if the if we cannot, if it returns nothing if we cannot perform the comparison at compile time, and otherwise returns a maybe boolean if it can be performed at compile time. Let's see where this is used. Yeah, that's okay. That's actually what it is, because here we go recursively on the fields, and if we encounter things that are not literals, then we just short circuit the entire thing because we don't have a value that can be compared at compile time. I still think it would be interesting as a matter of optimization to try to see if there are fields that are enough for us to just reject the comparison at compile time. For instance, we know this will always be false. We know this is always gonna be true, because if we could do that, this would open the door to a lot of optimizations down the line, such as, oh, this branch is always taken, this branch is never taken, and therefore we could probably optimize things a bit. But I think we had decided last time that I'm not going to do that at this point, and this kind of optimizations we'll do on the second phase of the project, because at this point I really want to make progress towards being able to actually compile things, which we are not able to do yet. So where is compare expressions used? It is here in comparison expression. Okay, so how do we do a comparison, compare two expressions? We analyze recursively on the left, we analyze recursively on the right. If their types don't match, the comparison makes no sense, we report an error. Otherwise, we try to see if we can do a comparison. And if we could do the comparison at compile time, there's still some comparisons we can't do at compile time, I suppose. Wait, no, this is okay. This case here is we couldn't do the comparison at compile time. We had put the same thing. This is we could actually do it, and we give a compile time Boolean expression. Okay, so we had actually finished this. That means indeed equality, difference, greater, lesser, greater or equal, less or equal. All of those are here. Okay. So what are we missing then? Addition expression is already there, isn't it? It is, okay, so I can remove this from the list I had copied from constants. Equality, difference, greater, lesser, all of those are there. Okay, so we have, for now, those are going to be errors still, because I have not yet implemented anything for vectors, arrays, and therefore for strings. So a range would be something that outputs. That being said, nah, I could start doing the skeleton of this, but the problem is I would not know what to output in the case where all the values are known at compile time, because I don't have yet any of the representation for arrays and vectors and stuff yet. So I think for now, this is going to be purely an undefined. This is going to be a compile time error. Like, it's going to be a panic if we try to use ranges in functions. But that's fine for now. I'm okay with this for now. Of course, it will have to be implemented before this thing comes out, but you know. And I guess we're left with assignment expressions and the compound ones. And those are gonna be tricky. Let's try to do assignment. So this would be here. This is the next possible case of an expression. And let's look at our AST again. Oops, what did I do? What did I do? I have messed up my layout pretty badly. Incredible. I have no idea how I've done that. Okay. So let's redo it very quickly. Come on. Up, this goes here. This goes here and here. I really want to find a way to actually save save this layout so I don't have to do it manually every time. I haven't done that. I just never close my Emacs between streams. And what is usually here? It is the not schedule. How's it called? Progress. That's what it is. There we go. So what I was doing was I was in core. I was shortening this a tiny bit, and here I was looking for the AST, because to implement the equality, the assignment expression, I need to know what is in it. And what is in it is, if I go look at assignment expression, it is an annotated expression on the left and an annotated expression on the right. That is interesting. Because, yeah, it will not always necessarily be a name on the left-hand side. There are different things we can assign to. For instance, a index expression, as in we have an array and we do array at index 3, that is something that can be assigned to. We have a few things like this, like a field access expression, foo.x is something that we can assign to. So basically there's a subset of expressions which are valid as left-hand sides of an assignment. We are going to need to evaluate the expression on the left and decide which ones are valid as assignments, basically. So this is going to be also a case of E1, E2. And those probably do have, yeah, those also have sub-expressions that we're ignoring for now. So for an assignment expression, what do? We're going to start with doing the same thing that we've done for the others. I'm going to shrink this because we don't need it anymore, which is we analyze the left-hand side recursively and we analyze the right-hand side recursively. Now, there's two things we need to check. We need to check that the types match, as in the type of the thing on the left is compatible with the type of the things on the right, which means we can actually do the assignment. And we need to check that the thing on the left is something that can be assigned to. The first check that I've mentioned, the type, is going to be an easy one, because I can go back to what we've done for the comparison functions. There we go. I'm actually going to copy all of this. So we have a left-hand side, which is a typed expression, which contains a type of a type T1 and contains some sub-expression R1. And likewise for the right-hand side, unless those two types are compatible, report error wrong type, and we're done. So assignment can only occur between a thing of a valid type that has already been declared, because otherwise it's a let statement. This is not an assignment expression, and something of a compatible type. Now, the other thing is we need to check what the shape of the thing on the left-hand side is. So we have to do a case R1, and we have to go through again, make this and do this. We have to go through this thing and decide which ones are thing that we can assign something to. Path is, field access is, call expression is not. We cannot assign something to the result of a function call, because function calls can't give us references or things that are assignable. Array expression is not, but index expression is. Let me just make a shoddy list here. So index expression, yes. A struct expression, no. Maybe there would be something like a let where we allow for destructuring a struct, but that would still be a different construct than this one, so no. Literals can't be assigned to. References can't be assigned to with the grammar of our language. All operations like this can't be assigned to. And I think any of the assignment things, a equals 3, will not return a reference to a. That is not something we can assign afterwards. So no, I think none of those can be actually used. Can I cast? No, that makes no sense. A as int equals 3 would be converting the type of a, which is not something that we would allow, so no. Okay, so the only 3 things that we can do an assignment on are those 3. That makes it a bit easier. Okay. So we go back here. And I'm going to delete this comment here. That is no longer needed. So this is the case where we are pointing to some kind of path. And this is a path info parameterized by the phase in which we are. We have already resolved that branch, which means the path info, let's see. A path info of that phase is a name type of that phase and the parameters maybe, which is a role. So it's going to be one of those. Okay. So we have already checked that the name in the path is something in the scope, which will be therefore... actually, we need to check what it is. Because if it's a path, it means it can be a bunch of those things, but not all of those are assignable. And in fact, the type checking might need... The type checking might depend on the kind of role, right? Or does it not? I'm thinking about function pointers. Function pointers are a thing we can assign. If we have a variable a that's a function pointer, yeah, we can assign it a function. That's fine. But how are function pointers handled in type comparisons? Where have we done... Is that in core or is that in context? Type matches. I don't remember where it is. It is defined in core. Okay. There we go. Okay. Okay. I do have a case for function pointers. Perfect. So that means my type matches call will check compatibility for function pointers. Okay, perfect. So I don't need to do anything special based on that. I think, I was going to say safely ignore the role. That's not true, but I don't need to redo a type check based on the role, I think. Okay. Okay, so let's go back to what we were doing. So here are the three possible cases. We found a path, which is one of those roles, basically. It is a name that we have mapped to something. We have found a field access expression, in which case I think no further check is required because we've already checked by virtue of having already gone recursively, we know that this field access is valid. We know the type of it, and we've checked that the types are compatible. So that's something that's okay. Let me explain. I've said assignment cannot be done with the left hand side being a function call. That is not something that makes sense. Because we don't have a value, we have a temporary value that is not used for something, and we're just like assigning something to it. That's weird, and we don't have references, right? However, if here we have a field access expression or an index expression, nothing prevents us from having the left hand side of that thing being a function call. Like we do call function foo dot x to get the x field of that struct that was written by the function foo, and here we can do a assign to it. So the question is, do we want to allow this, despite the fact that we're assigning to a temporary value that doesn't really exist yet? It's not a variable that we can point to. Or do we try to forbid it? I think I am leaning towards forbidding it. I think it doesn't make sense to allow assigning to what is essentially a temporary value. So that gives us two options. Either we change everything we've done so far on the analysis to keep track of whether an expression is a temporary value or not, or since this is the only case where this is needed, we do a ad hoc recursion there on the left hand side. From a performance perspective, it would probably be better to do it everywhere, like having always this function and annotate the thing with this thing is a valid left hand side or it is not. And I think that's the approach I want to do. So what I'm thinking is a thing is a valid left hand side for an assignment if it is any combination of things on a valid left hand side. And a valid left hand side is a specific path expression. Basically, something that points to a name that exists within the scope. A function argument, a local variable, something like this. Something that is named within the scope. On top of that, we can chain index expression, field expressions as much as we want, as long as at the core of it, there is a path expression that is a valid target for assignment, because it is pointing to the inner thing of something local. And I think we want to basically just check that we have this thing all the way down. Okay. So if we do that, I'm going to put this undefined here. I'm going to put this here. I'm going to check that what we have, the little we have done here actually compiles before messing all of the code again. Unused matches. Yes, that's correct. Yes, okay. I compile this project with WAR out of habit, which sometimes is a bit annoying when streaming like this. But oh well. I would rather be consistent in my use of WAR and not let a single warning escape. Okay. So that compiles. So we're on the base of something that compiles. I might even go the extra mile and nah, what we have done is so little. I'm not going to commit this. It's fine. Okay. So what I want to do is go back to the AST. I want to go to typed expression. Oops. AST. Typed expression. I really can't type. I'm sorry. There we go. And I want to change this, which is basically the annotated form of an expression after being resolved. I want to add assignment HS, which is a basic Boolean. That way, we don't have to go recursively in the case of the assignment. We can just check the left-hand side to see, hey, is that thing actually a valid assignment target? And now we compute this as part of the rest of the operation. Now, this is going to break everything because every single place where we create a typed expression is now broken. But I suppose we can just follow the compiler. I'm going to ask it to compile, and we're going to see every single place where we create a typed expression, and we are going to see every single place where we're missing a field, basically. And we can then fix that to put basically true or false wherever needed, which is mostly going to be in the... Actually, we're going to have two different cases. We're going to have to handle the case of constants and the case of functions separately. And I guess for constants, we can say false all the time because there is no assignment in constants. Okay. So here, what do we have? We have this pattern. Oh, so a int expression x is a typed expression of type int type with an int literal expression. And is that a valid assignment target? No, it is not. So false. Do I have two spaces here? I don't. Okay. Okay, so that's one issue fixed already. And next here, resolve the exp value. So this is a function in the context that, given a name that we have passed, so the output of the parsing phase, gives us a corresponding expression. So it checks that this name makes sense within the context where this thing is. So here what we check is the function argument? Is it okay, by value, by reference? Is it a let? Was it introduced as a let variable? Is it a built-in function? or is it some kind of top-level declaration that happens to be something that has a value, so an enum or a constant or a function definition? Okay. And in all of those cases, we're returning a typed expression. And now we have, I am tempted to make a change. I am tempted to make, I'm tempted to make this field the second field, because this one will always, well, almost always be the complicated one, and I want it to be last as a result, which means I have to go here and change this to be false here before the parentheses. Okay. Okay. So I can go back to context, where here I will be able to say, if something is a function argument in the context, that is something we can assign something to. Like, I have a function that takes an argument x, which is an int. I can perfectly assign a new value to that x. Oh, I think my microphone is a bit too close and saturating a bit. Let me move it a bit away. So this would be perfectly assignable, so true, especially for the ones by reference. That's the whole point. A let variable, there's no constant in this language. That is a true. It is valid, or even if there were, it is a valid thing to have on the left-hand side of an assignment. Functions, however, would not be. A built-in function isn't something that can be assigned to. And if it is an enum value, then this would be in the output of those functions. That's fine. And if it's a function definition, it is also not something we can assign a new value to. Okay. Yeah, we've made some changes to the AST, so we have to recompile everything, including the parser. I will replace happy with megaparsec at some point. This is a matter of when, not a matter of if. Okay, so here verify enum value is something that gives a type expression that checks that the name, we have something that we know is associated with an enum definition, but we want to check, is that the enum name, or is that the one of the constructors of it? And this only returns a typed expression in the case where it's one of the values, and a value of an enum is not something we can assign a value to. Okay. What else we have? We have, okay, that's all, I think. Perfect. That's all for this file, which means we should now be moving on to core and to all of the analysis. There we go. Okay. Here, this is just a case where we don't care. Okay. Likewise here, except this is not the first argument, it's the second. Should I make it the first argument, actually? I'm gonna change everything again. Okay, that's fine. I'll go back to built-in. And I move things again. I can do it with a regex, I think. Anything that is not a space star followed by false is replaced by false. Up, there we go. In context, let's go back to every instance of typed expression. There we go. I am almost tempted to actually go one step further, because I don't, as much as this is a Boolean, is this thing a left-hand side or a right-hand side? I don't like having a bunch of true, false literals in the code. Since there's only one in typed expression, this is actually not that bad because there's only one possible thing. But if we ever introduce a new Boolean to this thing, it's going to become very difficult to read. Like if there's like true, false, 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 true, false, or something like this in the constructors, what are those, right? It's not very readable. There is two solutions for this, which be one to create an enum that has like, even if it's two values, LHS, RHS, or something like this, that can like, and it's just assigned to each thing that makes it very clear this is something that goes on the left hand side, this is something that goes is valid also on the right hand side, or both basically. Or I could, and I'm tempted to go with that one, introduce new patterns. The same way I have done for this, and do that in the AST, and do something like that. I think LHS, RHS is not. I think C++ called those L values and R values, something like that. But that's basically the thing I'm trying to emulate here. Which is going to be, therefore, something that takes a path info resolved and an expression resolved. And returns the typed expression. And the pattern LHS expression given a expression type and an and an expression value. Actually, I can just make it point free. This is a typed expression true. I'm going to use the same semantic, L value, R value, I think. This is going to be R value. So this is an L value, which is a typed expression true. And we are going to have the same thing, which is an R value expression, which is a typed expression false. And now I can choose, instead of putting a bunch of trues and false in the code, I can replace every constructor call when I create one of those as being an L value expression or R value expression. They all map to the same constructor, so I don't have like different constructors to handle. But at construction time, I can make it very explicit which one I'm calling, basically. Okay. The only thing is, to have patterns, I need pattern synonyms, which I think is not enabled by default for the project. So here it is enabled for this module now. Okay, so that means I can go back to built-in, and I can make use of them here. This is an R value expression. And there we go. And now I can go back to context, and I can replace every instance of typed expression true with L value expression. And I can replace every instance of typed expression false with R value expression. There isn't a single one? No. Oh, is it because it might be because it's not just a single space? So I would need here to handle I'm gonna try not gonna try to do it with the regex. That's gonna be a mess. I suppose it's because I have a few that are split on several lines, like here, for instance. This false here means this is now an R value expression. False here, this is an R value expression. Typed expression here, which with false, this is an R value expression. The false is removed. Okay. Is that all for this file? It might be all for this file. Perfect. We can go back to core. So now, okay, I was adding here, I am matching some typed expressions for the purpose of reporting some errors. So I don't care about whether something is an R value or L value at this point. This is the same thing here. I don't care about it. Here, for the purpose of a comparison expression, I don't care about it. And the Boolean expression pattern will create it with as an R value, so something that cannot be assigned to, which is fine. Okay. Okay, here I am creating a typed expression. What is this? This is in the Go recursive function of... Is this... Okay, it's in the case of a constant. This is a cast. A cast will always be an R value. Cannot assign to a cast. And in fact, for a constant, it's always gonna be an R value because nothing can be assigned in a constant in the first place. I could try to make it to make a proper distinction R value, L value here, but I don't think there's any value in doing so, if I may say so, because nothing can ever be assigned in the constant in the first place. So I think I might just make everything in a an R value here. This returns an R value. Why do we have an undefined? Oh, because that's a string literal and we don't handle those yet. Here, the chirality of this expression doesn't matter. I'm not sure chirality is the right word, but you know what I mean. Okay, and then we move to struct fields. Okay, typed expression, typed expression. None of those create typed expressions. Here we do. Okay, perfect. And we're down to function expression. That's good. We're almost done. So a cast expression is not a valid L value, so that is an R value. This is still a cast. This is therefore an R value expression. We're still in the context of a cast. This is an R value expression. This is still in the context of a cast. That's an R value. That's an R value. Oops. Okay. Typed expression here as well. Okay. What's next? Here, okay, we're doing a field access expression. Now here I'm deconstructing the left-hand side of a field access expression. Here it is very important to keep the L value Boolean, because the result of this field access expression will be an L value if this thing, if its left-hand side was an L value as well. So here, whenever I return a typed expression, oh, that's interesting. So here I have, here I get, here this is, oh, I have found the value, this struct was a literal. This was a struct literal, and I have found, so I found the field at compile time. The thing is, since this was a literal, I want to mark the actual inner field as not an L value, even if it was. Or I need to make sure that the fields of a struct expression are always marked as being R values in a struct literal. Wait, is that true? Yes, it is. Because I can assign a struct to a value and then I can take fields out of that value, but I can't do temporary value dot a equals something. So yes, I will need to make sure that in a struct expression, every field is labeled as an R value. As a result, if I do this, there is no need for me to intercept here. The field will always be correct as an R value, L value. And here, if I don't have a struct expression, that means I don't know the struct at compile time, and therefore it's purely, was that left-hand side expression an L value or not? If it was something that could be assigned to, then taking a field out of it is something we can assign something to. So here the L value Boolean is propagated. And otherwise, that's the same thing. This is in the case where I could not find the type of the struct. When does this happen? When can't I find the definition if it's a template argument? If it's a template argument, I don't know what struct it is, and I cannot verify therefore that the field is valid or not. But okay, so that's fine. And here is the case where I can, and here we just therefore forward the L value Boolean unchanged. Okay, a call expression, the result will always be an R value. We cannot assign to something to the hello, how are you? You're good timing because I've not been streaming for 3 weeks, so you've just caught up on everything, and welcome back. Since I've taken a long break, I'm back to trying to clean things before going on vacation because I'm leaving on vacation next week, which is kind of the unfortunate timing. So I'm trying to finish a thing. Specifically, I'm trying to finish dealing with expressions in the context of functions. And to do so, I arrived at assignment operators, and I've made a change where now when I annotate an expression because I'm done resolving it, name checking it, type checking it, I also annotate it with a thing that indicates whether it can appear on the left-hand side of an assignment. So now I'm going back to every single constructor of an annotated expression to make sure I do include the information about whether it is valid on the left-hand side or not. So here a function call is not something that is valid on the left-hand side of an assignment. It is an R value expression. I'm using the R value, L value thing, which C++ uses here. All of those literals are patterns that include a false because those things cannot be assigned to. This, a string literal expression, I can already say is an R value, even though strings are not handled yet. I don't have array and index expressions yet, but index expressions, interestingly, will be L values as long as their left-hand side is a left value. So function call indexed1 is not something that can be assigned to, but local variable indexed1 is something that can be assigned to. Actually, here, path expression calls resolve exp value that we have called, that was in here, right? Yeah. So here we will already have L value, R value based on whether the name is something that can be assigned to or not. A function cannot be assigned to, a function argument can. Okay. So path expression, field access expression, and then finally index expression. Those are all the ones that we care about. Everything else, if it ever creates a typed expression, I can be very clear on the fact that it cannot be. It's always an R value. However, for references, I'm tempted, I wonder. Here I've made references as always being, oh, it's a path. I have constrained my language to the point where it's a path, so it's not an arbitrary expression, so I cannot give a reference to like a given array index or something like this. Maybe something we'll want to change at some point, but as a result, for now, I don't care about this. This is irrelevant, I think. Yeah, this is irrelevant. Okay. And as a result, this is not something that can be assigned to. This is an R value expression. Okay. Okay, likewise here, I don't care about what's on the... I don't care if it's an L value or R value. It will always be an R value expression because you cannot assign something to the result of a Boolean negation or an int negation. That makes no sense. So typed expression here, I don't care, and those are R values. Okay. So likewise, R value here. All of those make use of helper functions, perfect. And then we're back to assignment, which means I can quickly just finish. Compile time enum cast, that is always an R value we can't assign to a cast. Yes, we can't assign to a cast, that's correct. None of those binary int expressions are assignable because this is only used for subtraction, multiplication, division, and so on, which are things we cannot assign for. Those are our values. Okay. Likewise for those, R value. Comparison is the same. This is going to be an R value. I think we've already been through every single case of an L value for now, so I think at this point everything else will be an R value. So it's good to check, but at this point I probably don't even need to think. Any call to... And that's the end. Okay, let's see if I have missed anything. I have missed a few things. Oh, interesting. I can't... Oh, I didn't realize that. I cannot use point-free syntax for patterns. Okay. So an L value expression with an expression type and an expression value is a typed expression true of that type and that E value. and likewise for an R value expression. Okay. And now we wait for it to recompile. Okay. Okay, so I have a few cases. Well, perfect. That's the assignment 1. That's the one I was working on. Perfect. So that's perfect. Now we can just do, okay, we have analyzed the left-hand side. Is that an L value, something we can assign to? And I think we probably want to check for that first. I think we want to check first that something is assignable, and then if it is, check the types match. I think checking that the types match before checking that something that can be assigned to is nonsensical. Well, nonsensical. It's less important. So, unless is L value, we are going to need a new error type. I don't think we have anything for this yet. So error R value assignment, I suppose. Do we want to add anything at this point? Or will this be purely a matter of like the location at time of like... I guess I can include the expression on the left-hand side, like, hey, this is not something that can be assigned to. Expression resolved. So that means unless is L value, error R value assignment, and the thing we're giving is the left-hand side. Oh, I'm giving only the expression resolved. Should I give the full typed expression instead? Or is the expression resolved enough? The only additional information would be the type, and it would be the Boolean about it being R value or L value. That's not really needed. So I suppose having only R1 here is perfectly fine. Okay. So unless is L value, we report that's an error. And that's actually, I think I want it to be a fatal error. Oh, actually, it's in diagnostic now. So report will is a no-up that will be checked at a later point. Or I can just fail and it just will short circuit. Okay, and I want to do that, I think. So that's... Because reporting the type error if the thing is not assignable makes no sense. So yes, I think I want to do that. Okay, at this point we have checked. The thing is valid on the left-hand side. The types match. I don't think there's much else to return. There's not much else to check. And we're not doing code generation or anything at this stage. So here, I think the only thing left to do is to return something that is an R value, because it cannot be assigned to. The type of which will be the unit type. Oops. Will be a unit type, I believe. Let me have a quick look at my built-in types. Unit type, that's correct. Because this becomes something that can't be used, that doesn't have value, basically. So it's an R value expression of type unit type, and the expression is an assignment of the left-hand side and the right-hand side. When we do the code generation part, we will actually do more, but at this point, we've just checked, yeah, this is valid. I wonder if I want to annotate my assignments to keep track of where something is modified. But that's not something I need to do now. We'll change that if we need it for the lowering to AR, I think. Okay. And that brings us to the last things of expression analysis, which is, where are they? Those things. There we go, here. I'm trying to think, is there anything I want to put in common between the base assignment and those assignments? I think all of those will be the exact same thing, as in, those are only valid on numbers, and the only number type we have in our language is int. Therefore, all of those are only valid if both the left-hand side and the right-hand side are int, or compatible with int at the very least. So they're basically all doing this exact same thing, but checking that it is a number and that the thing on the left-hand side is indeed assignable. Yeah, I'm tempted to, like, I'm gonna keep this one here because it's different. It's the base case. I could actually even express those cases based on this one, but I think that's gonna be doing a bunch of redundant stuff. That's not great. So let's just do it as this is, how they call, are those compound assignments? Is that how they're called? A compound assignment operator, yeah. Okay. Which means it's going to be a tiny bit of duplication with the base case of assignment, but since it's a lot more specific, I don't mind that much. So let's copy this. And let's introduce compound assignment. Takes E1, E2 as arguments. And it does basically the same thing, which is we analyze the left-hand side and the right-hand side recursively. For the right-hand side, we don't care whether it's an L value or R value, it's fine either way. But for the left-hand side, we care that the thing is an L value, something that can be assigned to. If it's not, we reject it. And here the difference is, here I said assignment, this is an assignment expression. There we go. Here the difference will be, I will need to take the constructor as an argument to know what to construct. And here, this is no longer that. This is, it's a number on both sides, basically. So, unless type 1 matches int type, then error wrong type, expecting int type but got t1. Unless t2 matches int type, error wrong type, expecting int type but got t2. And then we return an R value expression of type unit type, and it's this constructor that we have are given as an argument here, So it is an addition assignment, a subtraction assignment, and so on. There's no inlining to do at this point because this is not the optimization phase yet. Okay, and that, at long last, except for the things we have no support for yet, such as ranges and string expressions and so on, this is, at long last, the end of the analyze function expression function. That took us a long time. Let's check it compiles. Not yet. Here, this is, oh yes, this is the thing I said I haven't done yet. That is a very important thing to do. So here, this is in the case of the function expression. Here, this is the case of a struct expression, which is a struct literal. A struct literal is an R value. You can't assign to a temporary value. So it needs to be annotated as an R value, but its fields need to also be annotated as R values. So here, this must be an R value. Wait. Oh, this is a field access expression. No, sorry, I'm wrong. I am on the wrong one. It's this one. Okay, for a struct expression, a struct expression is always an R value expression. But the important bit is I have changed my moderation settings to try to avoid this, but it still happens. The thing I need to change is I need to modify the result of this because it doesn't matter what the expression of the field is, even if it is a valid L value, it stops being an L value the second it becomes part of a field. So that means here resolved fields need to be annotated to always be R values. Okay. Do I create a function for this, or do I do it inline? Since this is the only place where this is required, I might just do it inline. I'm thinking about whether I want to... Like, I'm doing a double traverse because this is a container of pairs of name and expressions. So it would probably be at this level that I want to do that. Which would be tempting to make it as a function then. Or I simply rename this as the raw resolved field, and I introduce a new resolved field, which is for each pair of a field type and a typed expression of any arbitrary L value-ness, an expression type and an expression value in the raw resolved fields, we associate Or I can just do it as a double map, I suppose. Raw resolved fields. And the function takes a typed expression e-type e-value and always returns an r-value expression of the e-type and the e-value. Could this be actually done with lenses? Yes, it can probably be done with lenses, because this is gonna be raw resolved fields dot traverse. What's the name of the called? Expression is L value. Dot expression is L value. Is it this operator? I think it is. No, it's not. It's been too long. Let's see. Control lens setter. What's the operator I'm looking for? I'm the basic setting operator. Replace the target of a lens with a constant value. It was this one, I was correct. Okay. So it is this, and it becomes false. It is not an R value. Wait, no, this is this. There we go. On the raw result fields, I'm doing traverse, expression is a value, and I am assigning false. If I remember my lenses correctly, this should work. Okay. Okay. And then at the end, we output an R value expression. Okay. Let's check that. Where else am I missing it? Oh, here. For those, it doesn't matter. I'm destructuring it, but it doesn't matter what the actual L value-ness of either of those is. I don't care. Ah, cons is not a good name for this. It shadows something else. But if we are at shadow errors, it means I'm hitting warnings as errors, which is good. There we go. And hopefully this compiles. Not yet. Okay. What do we have? Ah, we're hitting errors in a new file. So core compiled. That's good. So something here in the simplification phase that happens afterwards is incorrect. But there's probably not that many issues because this is purely... There's nothing to simplify on the L value-ness, and it's information that's basically irrelevant at this point anymore. So I just forward it unchanged, I suppose. Okay. And here we have... Okay. In those cases, it doesn't matter what the L value-ness is. I don't care at all. And I'm always returning the actual inner expression. Yeah, this is fine. Yeah, okay. Okay. That compiles. So we are done. I'm tempted to push forward. We are almost done with the analysis phase. It won't be complete because there are a few features that are missing, but we're very close to being done. Because the only thing that's missing at this point is finishing statements. Because until we had expressions, most statements could not be analyzed. But now that we do have expressions, we should be able to start doing analysis of statements. Okay, so let's do that. Let's make progress on this, I think. And even though I don't have yet the infrastructure in place to do actual proper tests of the analysis because it's not finished yet, we're getting close to the point where I can do a stream of purely adding tests for those months of work. Let's do statements. We already do continue, break, and return, which are the easy ones. Why do I have a try there? What is this try? Is it coming from diagnostic? No, it's not. Is it coming from the monad? It is, okay. Oh, this is the air catching kind of thing. Okay. That means that if an error happens while trying to... Yeah, okay. We basically try to recover if analyzing the expression of return fails. We basically internally we still know that there's been an error, but we try to continue analyzing things from there, basically. Okay. So, what kind of other statements do we have to analyze? There's a lot fewer than there were expressions, so I'm hoping that this will go a bit faster. Statement, there we go. That's the list. God damn it. That's good enough. So here, if I go to analyze statement, we've already done continue, return, break. Perfect. Do I want to do... Because expression statements are basically trivial. Because I've already done all the work of doing analysis. So I guess the only thing I want to check, possibly in a expression statement, is that it does not return a value, and only valid statements are the one that return unit, because otherwise it means it's a computation whose value is lost. But actually, I probably don't care, because if I do that, it's probably the top level it's probably the side effects I care about, like the function calls or something like this. So if I if I have a function that contains foo, the function foo plus equals the function bar, maybe I don't really care about the result of foo plus bar. What I care about is the side effects that have been performed. I guess I could still issue a warning based on what the top level thing of an expression is. Because if it's something that creates a temp value and cannot perform side effects, I can probably issue a warning that like, hey, there's a temp value lost here, basically. That feels useful. Okay. So let's do that. We have an expression statement that contains an annotated expression. So that's a with location expression, which I can probably unpack here. Location. It's a with location of, so here for now, I'm not going to do anything yet with this, but I will have to when I do error handling. And the actual expression. What do? We do a try. So the whole point of try is basically doing error recovery. Like, I'm trying to analyze this expression, it contains an error. Do I short circuit or not, basically? I'm tempted to say that since a return statement will end a block anyway, I am tempted to say that any error in a statement basically short circuits the current block. Like, if this expression statement contains an error, I don't try to catch it within the handling of that statement, and I forward it back to the top level. Which means whatever function is calling the block can do a try on it and try to resume afterwards. Which means this would remove this. And that means that instead, in analyze block here, this is where I do a try, I believe. No, this is not where it is. It will be when I do analyze a statement that does a thing. This is where I can do a try around the analyze block. Yes, okay. Because this short circuits if any of the statements within actually has an error. I skip the rest of that block and I move back up one level, basically. Okay, that feels reasonable. Okay, so no try here at this point. So I have some kind of past expression. I can do an analyze function expression on this, which gives me a typed expression, which will only, like, this will throw, like, this will continue surfacing errors if something was wrong, but otherwise I get my typed expression. And the result of this will be, so that's annotated, resolved exp. Past exp. And here it would be enough to do. This is therefore the resolve version of this is we have an expression statement that contains this resolved expression. That's enough technically, but I think I want to do warnings here. I want to be able to warn, basically, we have a value at the top level that is unused. But I don't want just to do it by looking at the type and being like, oh, this is not a unit, therefore it's unused. I want to do it for basically what is the shape of the expression and only issuing a warning if the shape of it is something that emits a temporary value that should be caught, like a plus or a multiplication or something like this. So, unless the expression type of the resolved expression matches the unit type, in which case we don't need to do any check like this, it's fine. I will do a case of the exp value of the resolved expression. And here, basically, I want to check what are the valid expressions at top level, basically. It might be easier to, yeah, the ones that are valid at, well, the ones that don't yield a warning at top level would be, a call expression is fine. We're calling a function, it might perform side effects. Ignoring the result of a function call is perfectly fine. Array expression, no. Index expression, no. All of the literals, no. Reference, no. All of those, yeah, all of those create temporary values that should not be ignored. Except assignments, of course. Except assignments. So I think the only things that are valid, they're all valid at top level, but the only ones that do not result in a warning at top level are function calls and assignments, basically. Those are fine to have as a statement. The others will yield a warning for like, hey, this creates a temporary value that you're not using. Is that intended? Which is a warning, not an error. It's fine. So here, I do a case of the expression value, and if it's in any of those, here I don't need to like annotate the actual thing with like, is this fine as a top level, because it doesn't need any recursion. Any of those, and we do absolutely nothing. But any other will be a report of a warning. And what is that warning? Is it unused temp value? That's not exactly correct, is it? Because if I do a function call and I ignore its value, that's considered fine because functions can perform side effects. So it's not just about ignoring the top level temp value. Is it a suspicious top level expression? Suspicious is not a good word for this. Unexpected? Yeah, I guess unexpected would probably work. This is an unexpected top level expression. And this will take the expression resolved as an argument. And I need to make one change. I now have a second warning. Okay. So this is warning unexpected top level expression with the, which is this one. Okay. So that means if the expression within the function is a call expression assignment, one of the assignments, that's perfectly fine. Otherwise, if we have in the function one of the lines, one of the statement that reads a plus b semicolon, we're like, hey, that's kind of weird at the top level. Maybe that's wrong. Maybe you want to check that. Actually, what does Rust do? If I go, okay, that looks readable enough. Does this actually compile? It does. I have a bunch of warnings. Okay. Actually, I can probably just remove all of this. This was an old test that is no longer relevant. I probably want to keep some print here. Hello world. Okay. What if I have 3 plus 4 here? Unused arithmetic operation that must be used. Okay. Unused must use. Ah, yes. Rust has a notion of must use. And I guess most function calls will. I guess function calls you can choose to label something as must use. I guess this would be. I guess this would be something I could use a typed expression thing annotation for, as in label this thing must be used, this thing doesn't need to be used. And as a result, if at the top level something is ignored, I could use that rather than like looking at the shape of it. At the same time, for now, I think what I've done is good enough. Okay. Okay. Okay, so that's it for expression statements. What next? I probably want to do let statements first. Well, first of the ones that are left. Because let are the ones that introduce new variables in the scope, which means they modify the scope for the rest of the current scope of the thing. And since all of the others, well, if actually won't, but for will also introduce that, I think knowing how to deal with let first is probably, yeah, I think I want to deal with let and with if first, and it will make dealing with for and while a lot easier. Okay. So let's try a let statement. Let statement. We have only the let info, which I would probably want to just decompose here. That's going to be easier. So it's going to be some kind of let info here with the fields, which means I can go to a let info. That's the name, the type, the expression. Okay. What do we have to do here? We obviously have to analyze the expression, because if it's not valid, then we have to report an error. We have then to check that the types match, if provided. If the type of the let statement is not provided, then it will be assumed to be of the type of the expression. But if it is provided, they have to match. And I guess we should check that the name doesn't shadow anything. That would probably be a warning if it does, non-error, but that's something we probably want to check. Okay. So the two first are pretty straightforward. Okay. This is the let expression. Then we need to check the type. Which is going to be a traverse. And I think what we want is, if I go to context, I think resolve type is what we want. Because we have a path info passed, which is what we have here. Excuse me. And we want to obtain a path info resolved. Yeah, that's what we want. We want this to be a type. And the mode, is that in defining name? Or is it defining built-in? I don't remember. This is, oh, there we go, right there. Allow placeholder or forbid placeholder. This is a forbid placeholder. There's no, a placeholder is not allowed in the type. No, actually, this is an allow placeholder, but not at the top level. This is annoying. I guess it's fine. I guess it's fine for a placeholder at the top level. It's weird, but it's fine. No, this is an allow placeholder. Okay. Okay, so we go here. This is going to be a traverse because we are in the context. We have a maybe of the type. And what we're doing is we're doing a resolve type with allow placeholder. Okay. That gives us a type. I guess it means we should always take the type of a typed expression and always ignore this as in the result, because if it's a placeholder, yeah, we should always take the type of the actual expression. This is just for checking, basically. Okay. Although I guess, actually, I might want to do something a tiny bit more. So I might want to do... Yes, if I do a 4, it will wrap it back in a maybe, I think. So that's going to be for the let type, which means we are only going to do this if it's not, if it actually contains something. Otherwise, we will just get a nothing, which is fine. First, we can get the resolved type by doing resolve type allow placeholder on the past type. Then there is no point in doing type checking against this thing if it doesn't exist. So we're only do it in the context where we actually have a type. So we have a resolved type here, and we can do a unless. I can just copy this entirely. Except this will be a fatal error. Here we can't continue if we don't have an actual type, fatal. So unless this resolved type matches the expression type of the resolved expression, wrong type. I was expecting the resolved type, and I got... I'm just gonna actually name it. Nah, it's fine. There we go. Perfect. And the end of this block is just returning the resolved type, which means after this, resolved type here is a maybe resolved thing, which is what we need at the end. Perfect. So we've resolved the expression. We've checked that the type matches if given. At the type that was given, if the type was given for the let binding, that it's something that makes sense, and that it is compatible with the type of the expression. What's the last thing we have to check? So if it is a valid let binding as far as types and names and everything are concerned, we need to do two things. We need to check that it doesn't shadow anything, and if it does, emit a warning. And we need to modify the scope to register this name. I've done something similar for function arguments. Where is it again? I think it's above this. Here, for analyze function argument, I resolve the type. When is reserved? Okay, I can just copy this, I think. And go back here. Oops, wrong scope. This is below this. This is at this scope. So if it's a reserved name, but this is not an arg name, this is the let name. That's just an error, yeah. Oh, I don't have this name. Because that's... this name is the current function, I believe? Yes, it is. So that means if I need to be able to report that, that means the statements need to be aware of the name of the function. So that's an additional argument here. It's just a name, okay. Which means when we analyze a function and I traverse analyze block here, I need to give this name. And analyze block needs to know the name here as well. Maybe that's something I should put in the context, actually. Like, we are in the context of this function in the same way that I will at some point just store the location every time I encounter a new location so that error reporting can just fetch the current thing. Maybe the current definition is something that should not be in the error messages, but actually taken from the context. Yes, but I'm not going to do it now. So for now, I'm just going to do that. So here, function, I am calling analyze block with this name. Analyze block has the name, which is the function name, and gives it to analyze statement. Yeah, this should definitely be in the context and not be given as arguments to individual errors. Yeah. I am almost tempted to just remove it entirely from the errors. Because when I do annotate my errors, I will, at a later point, be able to say like, oh, in the definition of function bar, in file foo at line 35, this error. And the error doesn't need to contain which function I'm defining at the moment because it will be obvious from the context. So I think even though I need to do more work on the context, I think I'm just going to very quickly remove the names. Yeah, here the duplicate type parameter, this is the name of the thing, but that will be obvious from context. That name is not required. Likewise for... no, actually, the incorrect type parameter count, I need to leave the name here because this is when I'm calling something and I'm giving arguments and I'm giving the wrong number of arguments. So this one needs to say, actually. But where else do we have name? Cyclic definition, it should stay. Error enum duplicate entries. Yeah, this one will be also obvious from context. I don't need to put the name here. Reserved identifier, it doesn't need to be, the name doesn't need to be there. Okay. That's going to be a bunch of compile errors, which is fine, but it also means I can simplify a few things. I can remove this name from the analyze block. I can remove the function name from here. And here. And I can remove it from here and here. Okay. Okay. Which means this error reserved identifier doesn't require this name. The let name is enough. So, okay, if I am trying to do a let binding of something named, if would already be rejected by the lexer. So bad example would maybe int, which is a reserved name, that fails because that's a reserved name. Can't assign something that would shadow a reserved name. Then the role will be not function argument. This is going to be... This is a let variable. Why do I want the path info result? Oh, that's going to be the type, of course. So this is a let variable. Arg name is of type. Yes, that's correct. That's the same. If I try to look up the role of something and something comes up, report error warning. Well, report warning name shadow, actually. I would probably want this to be fatal, actually. Yeah, and just continue here. But that is a warning, so it can continue afterwards. And then I insert in my context, in the scope for the current scope, I introduce the thing, which is, okay, there's now a thing called let name, which point to this thing here, which is this let variable with this name and this type. Okay. And with that done, I still need to output the resolved version that will be used for the next phase of the compiler, the lowering to AR and everything, which will be a let statement, but resolved this time. It contains a let info. The let name will be unchanged, but the which order is it? Name type expression. This is now the resolved type and the resolved expression. Okay, that should be all for let statements. I have a typo somewhere. Resolved type. Okay. Yes, it's not arg name, it is let name. I have copy pasted this from handling arguments, and it looks like I have another one here. Okay. Aha. Oh, yeah, of course. Those are the places where I've included... Let me check what set type parameters do. Because it checks the type names. Yeah, okay, this is purely checking. It's checking that none of the names of the templates, yeah, that's correct. So here, the type name will be obvious from context. I don't need it in this error. I don't need it for this either. And that means I probably don't need it here either. I can simplify this. Okay. Okay, that's the same here. I don't need the root name here. Because I will always know... actually, currently my cycle detection is a set. So I don't know what was the last inserted value in the set. But adding a field of like, hey, current with the name is trivial. and something I will want to do anyway at some point when I start to do proper error handling. So yeah, I think I'm correct in removing the name here in a bunch of places. Yeah, here is where I inserted into the stack, which happens to be a set. So this is where I would also add it to the context to say, like, we are currently analyzing this thing. Okay. So I'm assuming, yes, here that this name is not required, which means it's no longer required here, which means it's no longer required here. Set type parameters. Set is a weird. Why did I call this function set? No, actually, it's not absurd. I'm setting them in the context. I'm actually doing some validation, but then putting them in the context are as things that are in the scope. So set is not a great name, but it's not completely absurd. Okay. This name can go away. It can go away for enum as well. It has never been needed here. It was never needed for a const either. And I think the only thing that's left is function. Which is here. What is this name used for? It is used in reserved identifier where we have removed it. And for set type parameters, which we have already removed it, name is no longer required. And I can go back to my top level function. It calls this, and I can remove this root name argument from all of them. Nice. Okay. Oh. Oh, the analyze function expression takes already a with location, so I don't need to actually unwrap it here. That's fine. Okay. I suppose, yes. As I was saying, here, this is the type of the thing we're gonna put in the context. So like adding to the scope, there is now a thing named this, which is the name of the binding of the let with this type. I am not gonna use the resolve type, which is a type annotation given to the let, because it is optional. And since it is optional and may contain placeholders, what I want to do is to use, actually, if it contains placeholder, if it contains placeholders, no, it's fine. I don't have, the type matches will take care of accepting placeholders as long as they have the right shape. But I know the exact type by looking at the expression, because there's no ambiguous types in this language at all, which is nice, because it's too simple for that. Which means the resolve type here can be ignored in favor of the expression type of the resolved expression. Okay. What else are we missing? Nothing. This compiles. Great. Perfect. Next. So we've done expressions and let bindings. Let's now do Let's do an if statement. Let's see. How hard can it be now that we have done all of this work? Surely. Surely this can't be too difficult. So, if statement, where we have an if info as an argument. What do? Well, we're going to do a bunch of checks, and at the end, we will output an if statement containing an if info with a bunch of things that we have not decided what they are yet. So, an if contains the expression, a body, and maybe an if else. Okay. As a result, I think I'm going to want to introduce a new function for this because I'm going to need to call this recursively. So this will be a basic call to analyze if info, or analyze if, I think. We have the if info as an argument, and analyze if will be something that takes an if info past and returns in our analysis monad an if info resolved. Okay. So now we have this if info that contains a bunch of things. What do we do? I suppose it's a matter of checking each thing. We resolve the expression. We check that there's no error there. It must be an expression. And we check that its type is Boolean. Then we check the body by going recursively through the block of statements, and we catch any error, because if any error happens in the body of an if, we will short circuit back to the if, but we probably want to resume afterwards. So maybe we put it in a try. And I suppose we do the same thing for the else. And it doesn't matter what we output in the case where we try and it failed, because anyway, on actual errors, the compilation will stop after this phase. It's just trying to collect more errors. So I guess for the else, we're gonna do the exact same thing, where we try for the block, not for the expression. Okay, so let's do that. So we have an if expression, which is an expression. So a resolved expression will be the result of doing analyze function expression on the if expression. Perfect. And we perform an additional check. We've checked that this expression is valid using the function we finished today, but we have one more check to do. We need to check that the expression type of the resolved expression matches Boolean type. And unless it does, we can report an error, fatal. Actually, do I want to report an error there? I don't think so. I think I want this error to short circuit, but I think it's worth trying to analyze the statements nonetheless. Like, okay, this is not a Boolean, but we can still try to analyze the statement. So here I'm going to do report. And at the end of this function, before we do a pure if info something, I will call the thing that forces validate. There we go. Okay. So it means if this is a fatal error, it's going to be delayed until this point. So what error do we want to report in the case where we have something that isn't a Boolean? We don't have a diagnostic for that yet. Let's create it. Error if exp not Boolean. And here's the expression. We might want the typed expression here, actually. Or do we only care about the type, actually? Yeah, we probably only care about the type. The place in the code will be obtained from context when doing error reporting. So the only thing we care for the error message is like, hey, we were expecting a Boolean, we got this. Unless I just reuse the wrong type. Error. Now, maybe having something that says explicitly this is in the context of an if, which would be something that would be a tiny bit more complicated to indicate via just context and location. I think I'm happy to just do it like this. So that's an error if exp not Boolean. And the type of the thing that is not a Boolean is the expression type of the resolved expression. Okay? Okay. So we've validated the expression of the if, which means now we just have to go recursively with an analyze block. I think it's called. Yep. And analyze block of the if body. And this is where I want to recover in case of error, because I want to be able to continue processing the current function. If something within the if block was wrong, we short circuit, but then we resume afterwards. So this is going to be in a try. Which means I will get a maybe value. Resolved body, which means I will need to do, I could do an on nothing, or I could just do a from maybe empty list. Is that a fold? Is that just a fold? DHCI to the rescue. Would fold of nothing, which is a maybe list of int, and I want a list of int. I think since lists are monoids, I think... Yes, that's correct. Okay, so this is just a fold, so I don't have to do a from maybe here, fold of this. That gives me an empty list of statements in the case where some kind of error happened, which means we're going to say, yeah, sure, here's the resolved version, it's going to contain no statement. That's fine, because since an error happened, the compilation will fail anyway. So it's not like we're going to emit code that contains no statement. So that's fine. So here, that's what we do. We get the resolved body. And then I suppose the resolved else will be purely a matter of traverse analyze else of the if else. When that's done, we validate so that if there's any error in scope that has any actual error, fatal stuff, we short circuit from this point, because maybe we just reported it, we have not checked yet. And we return a new if info, which is the... I suppose here this needs to return an if statement of analyze if of the if info. There we go. A new if info that contains the resolved version. So it contains the resolved expression, the resolved body, and the resolved else. No, okay. I was going to say, I have something in the context that checks, that it says whether we are in a loop or not, which is used to check the validity of break and continue statements. But I don't need to modify it because an if is not a loop. Break and continue are not allowed in an if statement. Okay. Is there anything else we need to check at this point? We've checked that it's a Boolean expression. We've checked the statements within the block. I think there's nothing else to do here. Okay, so what is left to do is to do the analyze else, which will take an else info past and return in our monad an else info resolved. And this will be either an else if. I'm almost tempted to not make it a case and just inline it completely. That's fine. It's an else if that contains an if info. In which case the result will be an else if that contains the analyze if of the info, or it is an else block that contains a block, in which case we are gonna do basically the same thing as this. It's gonna be an else block of fold of try analyze block of that block. Okay. Perfect. That should be it for if and else, which means this is done here. We are left with for and while. While is going to be the easiest, so let's do it now. Because a while statement with a while info, actually, I'm just going to name it if info here for consistency with other places where I've named it if info. There we go. A while statement contains a while info, which happens to be a while info that I'm going to deconstruct here because I don't need to introduce a new function for it because it's going to be somewhat straightforward, I believe. And a while info is, I think, fairly close to an if info, but simpler. Where are you? It's a while expression and a while body. Perfect. So we can do exactly the same thing we've done here, minus the need to analyze an else condition. So we analyze the condition in the while. We make sure that its type matches Boolean type. Otherwise, error while expression not Boolean. Which we need to introduce here. Okay. And the body will be a fold of try of the block of the while. There is no else. Validate to throw an error if this thing reported an error. And pure of a while statement of a while info of the resolved expression and the resolved body. Okay. Very similar to if, but without the need for recursion like this. Perfect. And now the only thing we're left with is for, but for we cannot finish today because the syntax of for, as far as I remember, requires vectors, and we do not have those yet. It requires the thing in the expression, excuse me, it requires the thing in the expression to be of a type that can be enumerated over, and that is not something we can do yet. So I guess we can still write most of the structure, but we cannot finish a for info today. Okay. So I'm still gonna do the start of it. So we have a for statement that contains a for info. The result will be a for statement that contains a for info, but with the result version of things. So first we need the name. So the resolved expression will be analyzing the expression of the for range expression to do validate range type slash range vector array type, which we can't do yet because we don't have anything for those yet. The type is not something, there's no type annotation. If the name is reserved, throw an error for the reserved name. Then we get the resolved role. Ah, we don't have a role for 4 variables, I think. We don't have a role for 4 variables, I believe. We don't. That's gonna break a few things, actually. The question is, can they be assigned to? I don't see why not. I don't see why they can't be assigned to. Because if they can be assigned to, I could consider that kind of a let assignment and reuse the let variable role for 4 variables, because it's just a variable that happens to be introduced by kind of a let binding at the beginning of every loop. And it is a valid thing to assign. It's just any change will be overridden at the beginning of... It's not that the changes will be overridden, it's that at every turn we're going to reinitiate a new let binding. We're not going to be modifying the value. And it's not going to be a reference, because we don't have those. I still think it's fine for it to be, yeah, I think a let variable is good enough. Yeah. And either we want to document this or just maybe entirely rename let variable. Maybe it should be like local binding or something, because we're using it for something that is clearly not a let variable. Okay, for variable name, the expression type of the resolved expression, that is correct. That is not actually correct. The type of this value will not be the type of the expression. It will be the type of whatever the range is operating against. So, inner type will be something that, given the resolved expression, check that it is something that can be iterated upon and gives us the type of the thing within. But we don't have that yet. So for now, this will short circuit and crash. Let's just panic completely. So here we will have to use the inner type for the let binding. And here we issue a warning if the the new variable is shadowing anything else. It's okay to do it, but we're still issuing a warning. Then we are adding this to the context. And the big... Oh, wait. We're not adding it to the context. We're only adding it to the context for the block. It does not exist outside of the block. Does the state monad have an equivalent of local, as in some kind of with pattern to make a modification that's only visible for a sub-expression? Let's see. With state. Well, except it does not restore the state afterwards, it seems. Hmm. Let's see. Let's try it just to make sure that I understand this correctly. I'm going to actually do a stack GHCI to have access to all the libraries. I want to be in this one. Okay, that's fine for it to not compile. I just want to test if I flip run state with an initial state of 0, and the expression in the statement that I'm doing is, let's say I do. Can I open? Yeah, I'm gonna open it. So first, I'm gonna print the result of getting the state, which is get, I think. Yes, it is. Then I'm gonna with state and the modification we're gonna do is gonna be +1, and the operation we're gonna do is gonna be print of get, and then we're gonna do a print of get. My question is the modification that happens for this with state, is it maintained after this expression or not? Does this last line print 0 or 1, basically? Well, it doesn't gonna print anything because I've made some mistake. Oh, because of course, yes. This cannot be state, it needs to be state t because I need to be in IO. So this becomes, actually, I'm gonna I'm gonna introduce a quick print state function so that it simplifies my work here. So print state is gonna be a lift IO of print of get. Okay. So now we go back to this. I do a flip run state t0 of print state with state +1 print state, and then print state again. Could not deduce monad IO identity. Yeah, that seems correct to me. Is it because it assumes that this has to be in IO? This can't be in IO. Interesting. Because GHCA is in IO. I'm confused. If I don't use this notation and I just do it as a inline thing here, run state t0 of just print state. Okay, now it's happy. It's just, it defaults the 0 to, okay, so if I do this, okay, print 0, returns the final state as 0. Okay, perfect. So now if instead I do this, and then this, and then print state, I'm gonna inline the whole thing. And here what I was doing was a with state, oh, it might be a with state t actually, because I'm dealing, yeah, that was the problem. That was the problem, of course. With state t of +1, print state. It prints 1, I was correct. The state remains modified after the call to with state. So with state is not doing what I wanted to do. Okay. That is somewhat annoying. I was really hoping that there was some equivalent of local, but there isn't. Okay, that's fine. We're just gonna do it ourselves, I suppose. Do I want to introduce this all the way to my prelude? Probably, actually. So here I have a bunch of things, and I will probably want to add. I don't know where, but it doesn't really matter. So it's going to be a with local state function that given a function from a state S to a state S, and some expression, actually, this is going to be in a monad state SM. So I'm in a monad M that happens to carry some state S. I have a function from S to S. I have a monadic action in that monad A, and I return a new monadic action in that monad A. That will be this one, but with the state modified by this temporarily. Wait, that means I am I'm discarding all the modifications to the state. That is on purpose. Wait. I'm already doing that. I am already doing that in the context of, maybe this is wrong. I am already doing that in the context of blocks. I am using the scope. Yes, here I am restoring only the scope. I'm not trashing any other modification, which would be a big risk in terms of, like, if calling a function has forced me to evaluate that function, I want the state to be carried over. So that means I actually don't want to do that. Not in a general way anyway. I will, however, want to have a way Actually, I don't. Because I think the context, the case of 4 is unique enough that I'm just not going to call analyze block in the context of a 4 and instead inline this. And that's going to be it. So here is where I was adding to the scope before, and I'm no longer going to do that. Instead, here I'm going to keep the previous scope. Then, after getting a copy of the previous scope, insert the let in the scope purely for the loop. analyze the block. So this will be the resolved body. And then restore the previous scope. And importantly, as a result, wait. I have a big issue that I need to fix. I have a big issue that I need to fix, which is when I do error recovery, I do it on analyze block, but that means if an error short circuits in this, I am not restoring the previous scope. So any variables introduced within this will be available past their scope if there was an error here that I'm trying to catch. So this is where I have to do my error handling, not at the statement level, at the block level. This has to be the fold of try. There we go. Which means any other place here where I have this fold in the while statement and so on is removed. Because I need to do error recovery to make sure that I do restore the scope always. Which wouldn't matter if there was no recovery, but since there is recovery, yeah, I have to do that. So this becomes an else block. There is no try. This is just an analyze. There we go. And no other fold, so we are good. This is here. And I can do the same thing for this very special case of the for statement, where this is a fold of try of this. And that way we recover, which means we always restore the context scope to the previous scope, no matter what. And now, when we've done this, we've analyzed the expression of the for. At some point, we will have checked that the type is compatible with a for loop by extracting the inner type here and doing this validation. We've checked that the variable name is not reserved. We've checked that it doesn't shadow any other name, which is just a warning, but still we have to check that. Then we recursively analyze the scope while introducing introducing a purely local kind of let binding into it. And at the end of this, we catch any errors, we restore the previous scope, and we create a for info that contains the for variable name that hasn't changed. The for range expression will be the resolved expression. And the body will be the resolved body, which will be invalid if there was any error, but the compilation overall will fail if there was any error, so it doesn't matter for this to be empty if there was any error. Okay. And with that, I think I can remove this because we have done all statements. Now, time to make this nonsense compile. Statements is not something that is in scope. Here it is called for body, I believe. Actually, am I just doing a case of brackets? I think bracket is IO specific. Yeah, bracket is IO specific. Okay. I guess I could introduce as like a kind of state bracket, but that feels overkill. Okay, so what's wrong here? I am in the for thing, and this calls let name. It's called for variable name. That's what it's called here as well. Okay, that should be all. Okay, and this compiles, which means, except for strings and vectors and ranges and things like this, at long last, we have finished the analysis. That was months of work. So now I will definitely dedicate a stream to just like testing this, purely just writing tests, figuring out a good way to test this and just writing tests. Because for now, for months, the only thing I've had was this file. It contains code that I was trying to parse and analyze. And I was very limited in what I could do. And all of these should be actual tests at some point. Okay, so now I can try a few things. Because now I have a bunch more things in my arsenal. What do I want to try? I want to try a very simple thing. I want a break statement. Oh, that's already going to be broken. Perfect. I have not done one thing, which is that in loops, which is while and for, I'm going to bring them together just because in both of those, I am more and more tempted to try to make a bracket thing for state, but well. Because here we have the same thing, was in loop, which will be a uses something from the context, which is called context within loop. I will set context within loop to, it's not this, it is this, to true. We are now within a loop. We resolve the body. And now within loop is back to whatever it was before we entered this one. And the same thing here, previous scope context within loop, was in loop first. Then we modified the local context, and then we restore what we had before. Let's check that this compiles. It doesn't, of course. It's just use, not uses. Any second now. Okay. So let's go back to this. I have made a function that contains a break statement at the top level. This should not compile. I get error break not in loop. Perfect. Continue should be rejected as well. Perfect. But now, if I do a while true, this should compile. Error rule not found true. Yes, this is true with a lowercase t. And now this compiles. And if I go look at the definition of test1, it is defined as a function named test1 that has no type parameter. It has an argument x, which is an int passed by value. It doesn't have a return type, and its body is a while statement that contains a typed expression which is not an L value, which is a built-in type boolean, which is a value which is a literal true, and the while body is a continue statement. And this compiled because this continue was indeed in the loop. And if I nest that, just to make sure that we do restore the context properly, and we don't like say, oh, we're no longer in a loop at the end of a loop. If I have two loops within, this should still compile just fine. It does. Perfect. And if the top level one here, if I have a for loop here, this would be, I know, that's not gonna work because I cannot test fors yet, because for x in something, we'll try to check that this is a vector, which we don't do yet. So while is my only loop I can test for now. Okay. Still, let's progress. Now, if I try if 0, I don't know, return, this should yell at me and refuse because error. Oh. Oh, because of course I got an error. Yes, I was grabbing test1 to get the definition, but yes. Error if expression not boolean. Perfect. While 0. Okay. But if I do if 0 as boolean, then this works, and this is an if statement with the expression, which is a typed expression, which is not an L value, of a type which is a built-in type boolean, and a value which is a literal false, because we have already, because we have resolved this 0 as boolean at compile time, and the body is a return statement, nothing. Okay? If 0 as boolean, else if true, else, and no statement there, and here I return again. This should also compile. It's fine to have empty statements. Okay. The top level if statement is this one that has the literal false because it's 0 as boolean. The if body is return statement nothing. The if else is indeed something, and it's an else if that contains an if info, where the type is indeed a boolean and the value is the literal true. Yes, that's correct. And has no body, but has an else, which is just an else block that contains a return statement nothing. Okay, perfect. That's working as well. If I try here having 3 plus 4, I think at the moment warnings will result in a panic. No, they don't. Okay, perfect. But where's the warning printed then? I probably don't print. No, there it is. Main warning unexpected top level expression. Perfect. Because we do have an int literal at top level which isn't used, which is something that is technically, oops, sorry about that. That is technically okay, but still suspicious. However, an unused function call should be fine. So if here I call foo, which is this function here, with x and 1, that's a function call. Sure, its result is an int that happens to be unused. Oh, actually, this requires a reference. So let's do instead 1 and reference to x. I am ignoring the result, but ignoring the result of a function call is fine. So the warning should not be there. It's not there. Perfect. So we've tested ifs, we've tested while, we've tested, well, not for, we can't test them yet. We've tested expressions. What else have we added today? Okay, so let's try something else. Let's try, I have let a int equals 0, a plus equal 2. That's fine. Yeah, and maybe here. No, it's fine not to have any. Yeah, it's fine. This function does nothing, but that's absolutely fine. That compiles. Well, that validates. If I look at test 1, we do indeed have a let statement that contains its name a, and the type is just an int, and the expression is a typed expression of typed int that happens to be an int literal expression 0. And then we have an expression statement, which is an addition assignment expression with the path info on the left, which is an L value. And we're assigning the int literal expression 2. Well, yes. Okay. Now, if I flip the statements, I should get an error for this not being found in the scope. Yep, role not found A. Okay. Now, if I flip this and I do if true this and this, A should be scoped, so this should work, but A equals 3 here should not. And I don't have the line error here, that's annoying. But I suppose if I comment this out, then it compiles. So it's this one that's broken, because at the end of the scope, A is not, at the end of this scope here, A is no longer in scope. Okay. And if I have another A here, but let's say that this one is a Boolean which happens to be false, and here I say A equals true, this should compile because the A in this scope is this one, which is a Boolean, and this A here is this one, so this should compile the types should check, but it should give me a warning that this A shadows this A. Warning, name shadow let variable A with of type Boolean, shadowed by let variable A of type int. Perfect. So we've tried lets, we've tried assignments, we've tried... all of this seems to be working. We can't execute any of it yet because we haven't done the lowering into AR and the code generation, but at least as far as validating all of this goes, this seems to be working, which is pretty neat. Oh, something I need to try as well. So I have some kind of A that is a int in scope. That's 0, that's fine. I want to try the L value versus R value thing. That means A minus 1 equals 0 should be rejected because this is not an R value. Okay, R value assignment. 1 equals 0 should be rejected because it's an R value assignment. Perfect. Calling bar on 0 and 1 and doing equals 0 should be rejected because a function call is not an L value. Okay, perfect. That's working. Now, I want to test a more complicated case. I need a struct. I'm going to call it S with the parameter t, and it contains only one field, which is going to be named S because I have 0 imagination of type t. There we go. That's a struct. Now, I will want... oh, did I fix... oh, writing the test, I found a bug. Okay. So, if I make a function, make big S, takes nothing, returns an S of S of S of int, And what it returns is return S, where S is an S in which S is an S in which S is 0. Now, if I copy this nonsense and I try to do this dot s dot s dot s equals 0, this dot s dot s dot s is valid, should be fine, but trying to assign something to it should be an error because the fields of a literal struct are not L values. Pass error. Operator greater than. Is it because in this context it has to be... No, it's not an expression context. Oh, because I have one too many, I think. Yes. And here I am missing a semicolon. Okay. Error R value assignment. Oh, okay, yeah, I suppose. I worried about this. Because here what happens is it has the compiler has decided, okay, this can be resolved as just being whatever this thing is that happens to be a int literal. Of course, that's an L value. So I should do something a bit more subtle, which I'm going to say let's have an A which is 0 and say A here, because A is an L value, but by becoming a field of S, it becomes an R value. So this should be still rejected. There we go. A path expression that is a variable A here cannot be assigned to because this is not a reference to A, despite the fact that we can simplify this whole thing to being A. We cannot assign to it. Okay, so that's correct. Tricky, but correct. Now, where there is a bug is if instead I do make big S dot s dot s dot s equals 0. Because... Wait, no, I think it's fine. I need to check. I need to check whether the result of a function call is probably labeled as an R value. I think it is. In which case, this will be rejected. Error R value assignment. Okay, no, okay, perfect. So this, I was afraid it wasn't working. No, it is not working as expected. I was afraid of it being accepted incorrectly. Okay, no, this is good. So trying to assign something inside a struct literal temp value not allowed. Trying to assign something of a field of a temp value obtained by a function call not allowed. If I had, yeah, if I had like operate, I'm already doing this with like negation and everything. A minus B is not something that can be assigned to. But there's another test I need to do. I need to do another test, which is now I have B, which is going to be this nonsense. And now, however, b.s.s.s equal 1 should be allowed. And it is. Yeah, this is unreadable. because it's a bunch of field access expressions all the way down. Yeah. But this is correct because now we're not trying to assign to a temp value, we're trying to assign to a field of a known value. So this recursive thing of trying to see, like, of carrying the L value ness through field applications, through field expressions, seems to be working as expected. So that's good. Okay, what else did we do this evening that we could test here manually before next stream? Now that the analysis is finally done, we can actually write some tests. For statement, while statement, if statement, we've looked at all of those. And I think this evening was mostly just, yeah, assignment. Okay. There's a few more things we haven't done. I need to check that if I have a boolean, then plus equal true is not allowed on it, because all of those require, actually, maybe let's say it's a character, and let's say C plus equal 2, this should be rejected. Warning name shadow, interesting. Why is C shadowing something else? Oh, because I have a thing named C here at the top level. Yep, correct warning. But, and otherwise, the real error is an error wrong type, where I'm expecting something to be an int, and it's actually a character in this assignment here. Okay. And with that, at long last, I think we're done with the analysis. There's gonna be so much to test. I have not a thing I have not tested at all is the type checking with type parameters in functions. A big thing that I have done here is I am using kind of the C++ model for type instantiation for functions. It's not great, but what I mean here is if I have something that is of type T here, and I try to do x plus equal 3, for instance, the only way this is valid is if the type T is compatible with plus equal. But at the time of analysis at the moment, I don't know what the type of x is because it's T, right? Which means what I'm doing at the moment is anytime a type parameter appears in an expression, I always accept it as being, yeah, that's a valid type for whatever the thing we're doing is. And I will have to have instantiation of functions, generating a new functions with a new mangled name with all of the type parameters the same way C++ does. Every time we figure out, like, oh, here we're calling the function foo with those arguments, we can instantiate it if it hasn't already been instantiated as part of this compilation process. And then we'll say, oh, you're calling test1 with T being int, and now we can redo all checking with this, or now you're calling it with character, and we have to recheck everything. The question is, how will I do the instantiation? And a part of me is tempted to just redo the same analysis we had before, which will duplicate a lot of work, but the upside being I don't have to redo all the type checking. I don't have to rewrite all of the code to do all the type checking on something that has already been done. Another approach would be I already have the resolved version of the function in which I have all of the typed expressions and so on. I can traverse that resolved version, so I don't have to do name resolving and everything, and I just do type checking on the way back, basically. Which would be a big rewrite, but fewer unnecessary operations. So that's not done yet. So as a result, this should compile regardless of the fact that like this only works when T is an int, basically. And it compiles, yeah, okay. And here, for instance, if I do if x do something here, this will only work if this function is instantiated with t being a Boolean, which is incompatible with this. But until I try to instantiate, I won't get any error messages because, again, type checking for type arguments is delayed until instantiation. So this should compile as well. Yeah. Okay. Something I would like to try as well, but I don't know exactly what I need to try. We need to try... I would need to try, but I will do this when I write tests. Type inference for struct expressions in generic functions with type arguments. So in a function that has something like this, if I'm doing something like x is an s of underscore, and its expression is the s struct with the s field initiated to x. The type of this field is of type t, so the thing here is of type t, but it is also a placeholder. Like there's a bunch of things here that might be a bit complicated. And error struct ambiguous type. Yep, this is an error. This should be fixed. Because here I could not find what the type parameter is, because it is something here. Yeah, okay. I should try to fix this because it should compile. That's valid code. So the problem comes from core, and it comes from the struct fields. Oh, interesting. Where are you? No, it's higher than this. There we go. It's here. So here the error we got is an ambiguous type, which is here. And that means that for one of the type parameters, we did not... Basically what this error means is... It means that here I did not specify the type of the argument. I could also have used this. So I did not specify what the type of the argument t to this thing is here. So it must be possible to infer based on the values that are given for the fields. So what this does is it collects all of the different types for the different fields, coalesces that to get a mapping from like, this type argument can be one of those, basically, and make sure that there's only one and unambiguous. And here, because of this being a type parameter, something goes wrong, and it doesn't find a value for the type t here. And I assume it's because the type diff thing fails with... Actually, no. I do have a case for this. So here, I am comparing the field type as declared in the struct and the type of the expression. And, oh, this is a type parameter of the struct. Perfect. So we are in this case, because the type of the field, as far as the struct is concerned, is its type argument. So we are in this case. Since a type parameter of the function will always match whatever is on the left-hand side, this is always correct. So we don't report an error wrong type. It is fine to use the thing we're using. So I am returning a mapping from the parameter name to the right-hand side. Okay. Aha, I have this filter mapping with the para mapping. So I get all of the diffs to list concat, okay. From list with, okay, that makes sense. So I think the bug is in this filter mapping function. Why am I doing this? Why am I doing this filter mapping? Because this is literally the cause of the bug. I am filtering out Oh wait, no, I'm filtering out placeholders. So that's not a placeholder. So I should be getting the type here, which happens to be type parameter. Okay, so it's not there. So I get this temp mapping but removing placeholders, but that's fine. And then I try to look the name of the parameter and I don't get anything. Fascinating. Okay, I am not sure I understand what's happening here. It is time for some good old printf debugging. I will want to trace show m. I'll first trace m debug starts here. And I will want to do a trace show. I think I want to see the all diffs first to confirm that the matching of the t of the s actually maps to this type, which happens to be the t of the function. And I will want to show that after doing this filtering, I still have that mapping in there. Okay. Because we went through this. The first case is the field type on the left-hand side is a parameter name. Is that because of the placeholder thing? It might be that. Okay. So let's try that. I'm gonna add debug trace to this. Import debug.trace. File that. Okay. So it is empty. Oh, wait. I did this in the wrong function. That explains a lot. This is function call args, and I'm not in the right thing. I need to be in the struct field. That explains a lot. If I'm debugging the wrong function, yes, I will get the wrong thing. So here, struct fields. There we go. That's what I wanted, which is very similar. So here, same thing. We do find one expression for a given field. We look at the type diff between the field type and the expression type. On the left-hand side, this is the parameter name for the argument to the struct. Okay. Okay, yeah, that should be here. Perfect. Okay. And now I'm doing this in the correct function, which is analyze struct field, which I believe for the purpose of this thing will only be used. It's going to be used in a few places. I will comment out this function here because I only want this test here. I want this to be inferred to be the type T of this function. It is empty. Let me confirm. This function is called for constants, but it should also be called for expressions. Maybe the problem is in functions. Maybe the problem is that in functions, I don't. No, I do call. Okay. So details of analyze struct fields. Okay, so I do call this to check. Wait, where does the fully resolved type? It is a result of analyze struct fields. That makes sense. So we do call this. Okay. Okay, so here I will want to do some debugging again. And I will want show me the field type. So what's the type, the theoretical type of the field as far as the declaration of the struct is concerned? Show me the expression of that we try to assign to the field, and then show me the type difference between the two of them. Maybe the issue is just the type difference. That would be the most consistent with the symptoms we are observing. I did not compile. Okay. So the left-hand side, the type of the field as far as the struct is concerned is type parameter T. I should probably use different names to distinguish them. On the right-hand side, the value we're given to the field is a typed expression, which is not an L value. And its type is the type parameter t, which in this case refers to the function's type parameter, and its value is a path expression, which is the function argument x, which happens to have a type, which is a by-value type parameter t. Okay? And then the type diff is empty list, which is the problem. Okay. So let's go look at type diff. Oh no. Oh no. Ah, fuck. Type diff compares a type expression with another one and tries to make sure that it matches, and it returns for every part that is different what the difference is. So for instance, if I have a vector of int and vector of string and I do type diff, it will give me a list of the differences, and the only differences will be a tuple of the pair int string. What is int on the left hand side is string on the right hand side. And I use this to basically like check that the types are valid. Like if you have vector of placeholder on the left and you have vector of int on the right, that's fine, it matches. It will still give me a diff of like placeholder to the other thing, but it is fine. And I use this to basically identify, oh, we have a placeholder and therefore I need to figure out what the type is, or we have a type parameter and I need to figure out what the type that corresponds to this, if it wasn't specified, is. The problem is I am only using the name of the type parameter, and in the case of our example here, it's called t here and it's called t here. So my code sees that as like, oh, yes, then the theoretical type of the field is type parameter t. The actual type of the field is type parameter t, which is this one. It's like, there's no difference. If I were to rename it to u, this would work. That is annoying. That is extremely annoying. That means that the name of the type parameter is not enough, and I need to carry with it something that identifies which one I'm talking about. Okay, because this should work nonetheless. So, okay, let's fix that. I might start actually by committing this, because I'm gonna now do a bunch of bug fixing, which is unrelated to what we have done so far this evening. Which means, well, it's not completely unrelated to what we have done this evening, I guess. No, it is unrelated. Struct expressions in functions existed before this evening. Okay, so yeah, I'm gonna remove, now we have found the problem, I'm gonna remove debug.trace. I'm gonna remove the trace here, trace show here, trace show here. I'm gonna commit this. Until we're on 1.0, my commit messages will be terse, and that's fine. And now we need to fix this. So the way to fix this, we're going to have to go to name here. And for type parameter, the identifier is not going to be enough. We are going to need the name as well. As in, to which top level declaration are we, like, from which type level declaration does this type parameter come from? Which, annoyingly, is going to undo a lot of the work we've done this evening. Well, a lot. A small part of the work we've done this evening. Because this evening, we removed one thing from core, which was that most of the functions that take care of the analysis, like an enum, a const, all of those top level things, do not take their unique name as an argument because it's not really required, right? It will be in the context. And now I'm going to need to know this so that when I initialize the type parameter, I know what unique name is associated with the thing I am currently building the type parameter for. But the thing is, I think I want therefore to do something I had planned to do in the first place, which is to add it to the context. Because that way I will always be able to have that when doing error handling at some point. Context current with a name. Okay. And I'm going to introduce a set current, which, given a name, will perform a action in the analysis monad. And what it's going to do is it's going to say context current is the name and context stack. Where's the set of things? Oh, I'm using... Okay, so I'm not going to do that. That's fine. That's fine. I only need to do it once. At the top level, here, analyze definition. Here I am setting local info stack to the thing, and here, before I do anything else, current context current is equal to the name, which happens to be root name. And now I don't have to pass this as an argument anywhere. It is always available through the context. Okay, now type parameters in name I have changed to also contain a name that uniquely identifies where that type parameter was declared. So I can differentiate T from the S struct and T from the function. Now that means I have the set type parameters function somewhere. There we go. That performs something in the analysis monad, which basically does a check and then puts them in the scope, hence the set verb, which is not great, but that at least makes more sense than if it were just a check. And here it means when I create a type parameter, I need to put the name of the declaration, and that is obtained as being use context current. There we go. And that should be enough because all of the functions, all the things that have type parameters use this set type parameters function. So that should compile just fine. But now there's a few things that are going to be broken. It's going to be every single pattern matching on a type parameter. Here, the initial context is wrong. Actually, is there a syntax for... What's the syntax for this? Is that the correct syntax? I never remember. No, it would be probably an equal, not a... God, I don't remember. Let me just try in GHCI. If I have a struct A that has an X, which is an int, and Y, which is an int, actually, those are double column because this is Haskell, not Rust. Okay, is the following expression valid? Yes, it is. Okay. So I'm going to do that. I'm going to name those because this is unreadable otherwise. Context location is the initial location here. The context fun type is unit type. I'm just going to copy those three. And now I'm missing the context current. And context current. Oh, I'm missing. Yeah, this is context scope. And context current. It doesn't make sense to have a default name outside of. So I just need to have some kind of placeholder default name that makes no sense here. It's kind. I don't like. I don't. I should probably use a maybe value there. In the sense of like, it makes no sense to initialize the context with no current name. So maybe the context should be initialized with a maybe, like with nothing there, and then I put the actual name when I start doing something. At the same time, there will almost never be any point in dealing with the context outside of the analysis of a declaration. So maybe it makes sense to always assume that I am currently dealing with a function and therefore there's always a current, which means I just put some placeholder there. Same way I do with location, actually. Yeah, okay. So this is going to be a name and it's going to be pure place top level, let's say. So it doesn't look too absurd. Can I make it, is it lazy? Are identifiers lazy? Can I make it undefined so that it's, if it's lazy, as long as this is never evaluated, this will never crash. And if it crashes, then we know we have a problem. And an empty list. Let's see, let's try. And if that's the case, I will replace with an actual error ice. There we go. Pass error here, because I did not close the brackets here. Okay, so now here, substitute types. Let me think. Let me think. This function is used when I have a type for each of the type parameters, here uniquely only identified by their names, and I'm replacing them within some type. I think this is fine because once I have resolved something, the only types that are left, the type parameters that are left, are the ones from the current scope. The ones from the definition are no longer there. Therefore, the identifier should be enough. And this, therefore, should not matter. Okay. This should be fine. Here it doesn't matter what's the source of the type parameter. Here it doesn't matter what's the source of the type parameter. Here it doesn't matter what the source of the type parameter is. Okay. Something I could have chosen to do is to modify my type diff function to assume that I'm never going to be doing a type diff with the same source for the type parameters on left-hand side and right-hand side, but that's a very dangerous assumption to make. I think I don't want to make that assumption. Therefore, I think this approach, while making me change more code, is better. And this is the function that we're trying to fix. Let me just quickly check this. Apparently, the thing I pushed, the test don't pass on GitHub. I'll have to fix that. Okay. So here now I have the name, and now they need to both be the same. They need to both be the same. So that's also n1 equals n2. Something that bothers me. Yeah, this is not correct. This is not correct. I am looking at the list of type parameters on each side. Like, okay, the types seem to match. Do their type parameters match? But the number of parameters should match. Here I'm discarding, in the case when the number doesn't match, I'm discarding things, which is not correct. I should be doing a zip on the longer, and I should be inserting placeholders on the one that is missing arguments. Yeah, I should be doing that. Is there... I'm looking for a function that would be some value a list of a list of a, and the list of pairs of a. No such function. Interesting. Zip is there, but there's no... Oh, of course. Hmm. No function for this? There's no zip with longer. Huh. I'm probably just not checking for the... searching for the right type. Do I have... Do I depend? I depend on extra. Okay. I'm gonna just check that extra doesn't have anything like this. Because there's a bunch. Data list extra. Yeah, zip with longest. Okay. Okay, that's exactly what I want. Okay, so this is not the thing I was fixing in the first place, but while we're at it, might as well. This is a zip with longest. Insert placeholder. And I'm gonna need import data list extra zip with longest. Okay. Here. And now insert placeholder is going to take the maybe value on the left, the maybe value on the right, and decide what value we create. And that's just simply a pair of from maybe placeholder L from maybe placeholder right. Okay. Okay. And now I'm checking the N1, N2 thing. Let's try to compile this. There's probably a few places where I'm not... Yes, N2 here. There's probably a few places where I'm not matching type parameter correctly yet. We're going to have to fix those. Yeah, two type arguments here. This is always true. Type parameter always matches with anything. That hasn't changed. Trace is no longer in scope. Let's see what I'm missing. Ah, yes. This is not just inserting a type. I think there is a placeholder type pattern. Okay. Interesting. I wonder why this is failing now, where I have not changed this. Oh, because here, this requires... There we go. There we go. Type parameter here. What am I doing here? Okay, so this is basically re-implementing the type matches function, because I am not doing the normal kind of type match, I'm doing a type diff, so I have to manually handle a few things. The name is only used as far as the type diff is concerned. Here, the name has to be on the left-hand side. the one from the struct. And here, yeah, it doesn't matter. Yeah, okay. Okay, this is for function call arguments. This is for a type diff, so likewise, I think this doesn't matter here. This doesn't matter here. Okay. I just don't want to make the assumption within the type diff function. For the colors of type diff to make assumptions about the names, where the types are coming from is fine, but within type diff, I don't want to. Here, this is... I'm trying to cast to it something that's a type parameter or from a type parameter. I can't check that. That's fine. It's always allowed. Likewise here, because we delay type checking until the function is instantiated. And likewise here. Yeah, I think just changing type diff would have been fine, but I, again, don't want to make the assumption that I know how type diff is called. I want it to work regardless of how it's called. So colors of it can make the assumption, but otherwise I don't want to change that. Okay. This compiles. I'm surprised that, like, since the tests passed here, I wonder what's not working on GitHub. I'll fix that later. So now if I go back to this should compile. It does. Okay. Let's have a look at what's happening here. Test warning name shadow. Interesting. Argument X is shadowing. Yes, this X is shadowing this X. That's a perfectly valid point. Let's create Y. Okay. I still have... No, okay. No longer any warnings. So this is a function definition. The name is test1. It has one type parameter t. It has one argument x, which is given by value. And it happens to be a type parameter named t, but introduced by test1. Okay? It returns nothing. It doesn't have a return type. The function body is a let statement where the name is y, the type is just a s defined in the module main with no name parameters. That's correct. We did not give any. And as a result, there is only one argument, which is a placeholder, because we did not specify... Oh, it's the name. No, the name parameters are empty, not because we didn't specify anything, but because this is going to be used for as mangling for functions that are instantiated, and at the moment, so that's unrelated to S. We do have an argument, which is a placeholder because it was not given. The expression of the let is a typed expression, which is not an L value. Its type is an S with a path parameter, which is a type parameter from test1 t. So we have identified that the type of the argument to S is the type parameter of the function. And the value is a struct expression of type S with likewise a argument which is the t that was declared in test 1. And it has a field S which contains a typed expression which is a t from test 1, which happens to be a path, which is the function argument x, which itself has the type. Okay, this worked. Whew. So type we fixed by introducing a source for the type argument name. We fixed type inference when there's a name collision between the type argument here and the type argument here. That was ugly, but this is fixed now. Okay. And my point was still that I wanted to check that kind of stuff. If I return y.s, this should be allowed despite the fact that this is not an int, it is a type t, because until we know what type t is, we cannot disprove the fact that it can be written as an int. Yep, perfect. And if I do a cast here, allowed as well. Okay, so I guess next I have, in theory, only one more stream on Thursday before I go on vacation. I'm going to try to do two, either tomorrow and Thursday or Thursday and Friday. I don't know yet. There are two things I want to do before I go on vacation. Try to do some of the function instantiation so that we can actually finish the analysis and really move on to the next part of the compiler when I'm back from vacation, and work on tests. Because the only test I have for the entirety of the analysis that has taken us months to write is this file. That's not enough. We need more tests. So I think it's going to be one stream is going to be just writing some tests. For now, I think this is going to be all for this evening. That was a lot of progress. We're finally through the analysis of functions. Just going to commit this. Add source for type parameters to fix type diff. And I'll go check what's wrong on GitHub and maybe fix that off stream if it's something completely unrelated to the code. Okay. Thank you everyone for tuning in. I'll be back either tomorrow or Thursday, depending. Thank you again, and I'll see you then.